was really not a great place for environment. So why? We don't know.
All right, and as you say, there's two kinds of questions. Why? What is the answer to that question, and why are we not very good at looking for answers to that question at a systematic level? But let's not go there now. Let's hand over to the next speaker. So thank you, Didier. The next speaker is John Danaher, who is from Ireland, and he's going to introduce his talk. Over to you, John.
Okay, thank you, David, and thanks for inviting me to participate in this conference. It's, I think, a rare opportunity for me as an academic that deals in the philosophy and ethics of technology to engage with a group of people who are, I hope, broadly speaking, optimistic about the future. Most of my time is spent looking at reasons why the future is a bad thing and why technology is terrible. So it's nice to look at a set of perspectives that is a little bit more optimistic. So look, in the short time that I have to talk, I just want to try and make an argument that maybe latches onto part of the Viridian Declaration. Specifically, I want to make a plea to think more carefully, systematically, and scientifically about how to harness human and machine intelligence to solve the ecological, sociological, and technological problems that we currently face. All right, so I'll just load up my talk here. Okay, so I'd probably go a little bit further and say that thinking systematically and scientifically about how to harness human and machine intelligence is the greatest challenge of our times. And I think there are some tentative and fascinating attempts to develop a scientific inquiry into collective intelligence, but they are currently insufficient and we need to do a lot more. So to try and support this argument, I'm going to explore 4 propositions in the remainder of my talk. So the first proposition or claim I want to explore is the notion that in order for our societies to have a bright and sustainable future, we need to invest in our problem-solving capacity. Since on my view, intelligence is equivalent to problem-solving capacity, another way of putting this is to say that we must invest more in our intelligence capital. Now, what's the support for this? Well, I take part of the argument here from Joseph Tainter's famous study of the collapse of complex societies. So some of you might be familiar with this work. It's popular in the ecological movement. And Tainter's book looks at historical complex societies, all the classic examples, Western Roman Empire, the classical Mayan civilization, ancient Egypt. And after reviewing and dismissing the typical explanations for understanding the collapse of these complex societies, which includes, to some extent, the claim that environmental damage and destruction is responsible for their collapse, Tainter concludes that it is insufficient problem-solving capacity that is the root cause of civilizational decline. Now, his argument is relatively simple and consists of 5 main claims, which I'll briefly review. And I apologize for the next slide because some of the text probably will be quite small on your screen, but I'm happy to share this imagery afterwards. So he starts with the claim, which I just outlined there, is that human societies are essentially problem-solving organizations that generate benefits for their members. They solve certain existential and psychological problems that their members have. Food, clothing, shelter, and also a sense of meaning and purpose in life. In order to sustain themselves in the long run, they must continue to solve problems and generate benefits. Now, like all organizations, human societies must capture and expend energy of some kind in order to sustain their problem-solving capacities. Classically, societies have captured energy by foraging, farming, burning fossil fuels, and also to some extent through war and imperial expansion. It's a way of increasing the amount of energy that they can capture and expend to solve problems. So, Tainter's key insight is that in order to sustain themselves in the long run, societies all face a basic cost-benefit equation. The benefits of increased expenditure on problem-solving capacity must exceed the costs in order for a society to be sustainable. Now, roughly speaking, increased investment in problem-solving capacity usually yields higher net benefit returns, but this typically comes at an increasing per capita or per unit cost for these benefits. So that, the marginal returns on increased investment starts to decline at some point in time. And if the marginal costs of investing in problem-solving capacity start to exceed the marginal benefits at an increasing rate, you get societal collapse. There's going to be a rapid and significant decline in socio-political complexity. And this is a bad thing if you care about the sustenance of civilization in the long run. And the only way that societies really avoid this dilemma, apart from by collapsing and fragmenting, or ending up in some state of civil war or strife, is if they can develop some kind of breakthrough technology that either reduces the costs involved in problem solving or increases the benefit or net returns in problem solving capacity. So historically, classic examples of such innovative breakthroughs include breakthroughs in methods of food production. You could argue the facilitation of open markets and trading is another kind of innovative breakthrough that facilitates increased benefits and reduced costs, new techniques of management, new forms of energy production, most recently then computing power. But what I would argue is that each of these technological breakthroughs is ultimately made possible by intelligence. And hence it is our intelligence capital, not technology per se, that should be the main target for investment if we are to sustain our civilization in the long run. That leads me then to my second proposition claim, which is that the most effective forms of intelligence are collective in nature, not individualistic. In other words, we should focus primarily on making teams of humans and machines enhance their collective intelligence, and not solely on making individuals more intelligent. Now look, we all like to celebrate lone geniuses like Einstein, Newton, Darwin, but the reality is that lone geniuses play a limited role in the sustainability and success of human civilizations in the long run. It is rather collections of individuals coordinating and cooperating their intelligence that make civilization possible. Now look, there's a certain amount of common sense behind this argument or claim. You just look around and consider how dependent you are in your daily interactions with other people and their capacity for problem solving to solve your basic existential problems. But there are some books that have defended this idea that it is collective intelligence that is responsible for the success of human civilization in much more detail. So one of my favorite books in this regard is Joseph Heinrich's The Secret of Our Success, which presents a good body of evidence for thinking that it is collective intelligence and not individual intelligence that is responsible for the success of human civilization. And there are many examples of this in the book, but he uses an interesting thought experiment to set up his main thesis that collective intelligence is what matters, which is a comparison between a human and a chimpanzee. And he asks the question of what would happen if you dropped a chimpanzee and a human into the middle of the jungle, who would survive longest? Who would you bet on surviving more than a few days? And Heinrich says you bet on the chimpanzee every time. And why is this? Well, Heinrich's claim is that because individual humans aren't really capable of doing much by themselves, they depend highly on their cultures, their collaborators, and their technologies to get by. Now, technologies play a crucial role in human collective intelligence structures, or group minds, as you might call them. Humans are, after all, a technological species, and one of the main products of our intelligence is technology. From stone axes to nuclear reactors, groups of humans create and use technologies that enhance our collective intelligence. Now, artificial intelligence is one of the most recent manifestations of human collective intelligence. And some people worry that it's going to replace or undermine human beings. And some of these fears might be well founded, less so, but it's not a debate that I want to get into right now. But what I will say is that we shouldn't think of, the best way to think about AI is not as something that's separate from or alien from human collective intelligence. Ideally, what you want to happen is to view AI as a partner or assistance to human intelligence, and as something that needs to be incorporated effectively into our collective intelligence structures. And indeed, incorporating AI into our collective intelligence structures may be the technological breakthrough that we need to avoid Tainter's dilemma about this decline in marginal return on investment. This brings me then to my third proposition, is that I think we can think systematically and scientifically about collective intelligence structures and how best to design them and maximize their benefits relative to their costs. So we know totally and historically that some groups are more successful than others. And we also know that there are many different designs on group structures that we could implement. And we are now starting to develop a scientific field of inquiry into collective intelligence. And this is the main argument that I'm trying to make here, is that I think it's important that we double down on this scientific inquiry if we are going to survive and thrive in the future. You know, the work of Thomas Malone and his colleagues springs to mind here. They've developed some insightful and innovative methods for understanding group intelligence. They've developed this notion of a group intelligence test, which is similar to an IQ test. In initial experiments on the idea, they find that you can seem to measure collective intelligence. Now, there are some factors that seem to correlate with more intelligent groups. There's no causal links per se yet. Some of the factors that seem to correlate with increased group intelligence include cognitive diversity within the group, not all kinds of diversities, but cognitive diversity specifically, social perceptiveness within the group, how empathetic and understanding the members of the group are, quality of participation within the group. And also one of the findings that they have from their studies is that groups with more women tend to be better than more intelligent than groups with fewer women. And it's not just that it's equal proportions that are better. Their findings seem to suggest that more women are generally better as groups. There's an explanation for why this might be, which is that women tend to be more socially perceptive on average than men. But you know, Thomas Malone would caution that you shouldn't overinterpret the data from their studies so far. There's a lot of noise in them, and these are just kind of tentative studies, but I think they're indicative of the kind of thing that we should start doing. I mean, the one thing I will say is that the correlation between cognitive diversity and group intelligence seems to be fairly robust, and there are some independent reasons for thinking that it would be indicative of increased collective intelligence. All right. The other thing as well is that we can think about the different types of collective intelligence structure and their distinctive costs and benefits. Now, in principle, there are many different group structures as there are groups, but one of the things that Malone argues in his work is that there are 5 basic types of collective intelligence structure, and they each have their own distinctive costs and benefits. So the 5 are, there are hierarchies in which you get one individual or small group that solves problems for a larger group, often supported by some kind of legal bureaucratic agency or set of agencies. You have democracies. David is going to talk about this next, in which you have all members who have a say in how problems are solved through some kind of formal voting procedure. You have markets in which people are left largely to themselves, but they then transact and trade each other, and kind of group problem solving emerges as an emergent property of these individual transactions. Markets usually depend for their success on some background hierarchy and democracy, by the way. They usually can't function perfectly independently of these things. You then have communities where there's no real formal mechanism for group coordination, but there's instead a reliance on informal social norms, and the group solves problems by coordinating on these norms. And then kind of a default category, Malone says there's an ecosystem, which is, there's no structure at all. It's kind of like a Hobbesian state of nature where the powerful solve group problems. Right, so Malone argues that each of these structures has different costs and benefits for the members of the groups, and there's different ways of distributing the benefits to the members of the groups. So hierarchies often produce significant group benefits, but they tend not to distribute those benefits very widely, okay? They also tend to be quite costly to maintain. You need to create cultural myths, religions, laws, enforcement agencies to maintain the hierarchy. Democracies are somewhat similar. They produce significant group benefits, but they're also costly to maintain. And they do usually distribute group benefits more evenly. Markets and communities are different again. They produce group benefits at a lower cost because there's no formal infrastructure for maintaining the group, say. But they're more unpredictable in how much benefit they generate and how they distribute those benefits. And technology plays a key role in maximizing the benefits of each type of group, both by reducing the costs of group coordination and decision-making, and also increasing the net benefit or return to the group. So, I mean, Malone's framework is just a preliminary one, but I think it's a useful example of how we might start to think carefully, systematically, and scientifically about collective intelligence. And that brings me to my last proposition or claim, which is that I think we should be pluralists, not monists, when it comes to investment in and design of collective intelligence structures. So look, I think it's tempting to think that we need to find the best type of group structure or that one structure is necessarily better than the others. You know, they claim that democracy, for all its ills, is better than all the rest. But I think we should avoid this temptation. You know, the reality is that modern societies blend different kinds of collective intelligence structure. I mean, to stick with the framework I just outlined there, even in liberal democratic states, it's not the case that we rely only on democratic mechanisms or group structures. Our democratic political institutions include elements of hierarchy, legal bureaucratic hierarchy, and they may well depend on informal community norms to be sustained in the long run. And these democratic institutions themselves often support and sustain markets. Another important point here is that the kinds of structures that we use can often decay or stagnate over time. They may cease to function as effective problem-solving mechanisms. We may need to adapt and redesign them when this happens. And many people argue that this is actually now happening to mature democratic states, because a democracy's primary tools for increasing its problem-solving capacity and its perceived legitimacy to the group is to enlarge the voting franchise and increase transparency and accountability. But there's several theorists in the last few years that have argued that mature democracies may have hit the point of declining marginal returns when it comes to these mechanisms. So there's a real challenge here as to how we can redesign democracies and reinvigorate their problem-solving capacity. And I believe David is going to talk about this next, right? But my bottom line is this: there are different kinds of structure that are optimal for different kinds of problem, and figuring out which structure is optimal for the set of challenges that we now face, be they ecological, sociological, or technological, or political, is something that is a project that we should focus on and invest in. I think we've started to take steps in this direction, but we need to do a lot more than we're currently doing. So that's the end of my talk.
Thank you so much, John. Mark Rue is going to take over the moderator role now. I'll just note that I echo your praise for Thomas Malone's